On one planet, roughly 64 light-years from Earth, the wind doesn't just blow. It roars, 7 times faster than the speed of sound, carrying glass through the atmosphere sideways instead of letting it fall. The planet is called HD 11897333b, discovered in 2005 by a team of French astronomers, and it belongs to a bizarre class of worlds nicknamed hot Jupiters, gas giants that orbit their star at an almost reckless distance. HD 11897333b circles its star roughly 13 times closer than Mercury orbits our Sun, completing a full orbit in just over 2 Earth days. That proximity locks it into a fixed orientation, one side permanently baked by unrelenting starlight, the other permanently plunged in darkness, never rotating to share the heat the way Earth does. At just 64 light-years away, it happens to be one of the nearest hot Jupiters we can observe passing directly in front of its star, which has made it one of the single most intensely studied exoplanets in the history of astronomy. In 2013, observations using the Hubble Space Telescope revealed something that initially sounded almost comforting. Seen from a distance, HD 11897333b appears as a deep cobalt blue dot, eerily similar to how Earth looks from space. The resemblance ends immediately after that. Earth's blue comes from reflected ocean water. This planet's blue comes from something far stranger, a hazy, blowtorched atmosphere filled with silicate particles, essentially the same material that makes up glass and sand here on Earth, scattering blue light across its scorching sky. The daytime temperature on HD 11897333b reaches nearly 2,000 degrees Fahrenheit, hot enough to melt those silicate particles into tiny droplets of liquid glass. Under calmer conditions, that alone would be strange enough, but this planet doesn't have calm conditions. In a landmark 2013 study, astronomer Tom Louden and a team at the University of Warwick achieved something that had never been done before for any planet beyond our solar system: directly mapping its weather. Using a clever technique built around the Doppler effect, tracking subtle shifts in starlight as different parts of the planet's atmosphere move toward or away from Earth during each transit, the team measured wind velocities on opposite sides of the planet independently for the very first time. What they found was staggering: a belt of wind circling the planet's equator, blowing from the scorching day side toward the permanently dark night side at speeds reaching roughly 5,400 miles per hour. That's not just fast. It's about 20 times faster than the strongest wind ever recorded on Earth, fast enough that any liquid glass caught inside it wouldn't simply fall toward the ground. It would be hurled sideways instead, an entire planet's rain falling horizontally rather than down. And the atmosphere keeps getting stranger the closer scientists look. In a 2024 study using data from the James Webb Space Telescope, a team led by astrophysicist Guangwei Fu at Johns Hopkins University identified water vapor, carbon dioxide, and heavy metals threaded through the planet's turbulent air, along with something considerably less pleasant, hydrogen sulfide, the same foul-smelling gas responsible for the odor of rotten eggs here on Earth. The team also found the planet's atmosphere carries a metal content roughly 3 to 5 times richer than its own host star, a detail that helps scientists piece together exactly how violent, metal-rich worlds like this one actually form. Put all of that together, and HD 11897333b becomes one of the most viscerally strange places we've ever managed to study in real detail. Not a distant abstraction, but a planet close enough and bright enough for astronomers to build an actual working weather map, tracking real wind currents circling an alien world thousands of trillions of miles away. It's not a candidate for life, and it never will be. But that's precisely what makes it so valuable scientifically. A natural laboratory sitting close enough for us to study an entire violent class of planets in genuine detail. One glass storm, one sulfurous breeze, one impossibly fast wind current at a time. What do you think? If you could somehow witness this planet's sideways glass rain safely from orbit, would the sight be more beautiful or more terrifying? Let me know in the comments. Subscribe, because next time we are covering 3I Atlas, an object from outside our solar system that is passing through our cosmic neighborhood right now.